close that off. And excellent. I was slightly worried it wouldn't render properly, but it actually looks readable. Okay, good. So out of interest, who here is already familiar with object-oriented programming paradigms, etc.? Few of you, okay. This should work out well because I've designed it, well, this lesson at least, so that it will give you an intro into the general concepts and then how to apply that in terms of C++ as a language. Tom, could you do me a favour? Two things actually. You recharge my phone in the colours. Okay, so I'm fighting with a bit of a cold at the moment, but hopefully I'll get through it okay. So the obligatory slide, of course. We always love to have feedback from you. You can either join us on Slack. It's probably the easiest way. There's a link here, slack.cpp.al, L for Lima. Just give it your email. That will then forward into Slack's API. It will send you one back, and you can come join us in our live chat. Right. So, they go away. So with that said, let's get cracking. Right. So the motivation for OOP. Probably the most key point is that it empowers you to model your code as objects. So in terms of your programming, obviously one of the examples I'll use here is things like a student. So a student is a kind of object. A car is a kind of object, right? So the idea is to, given any kind of problem, any task that you have to do, you want to find ways that you can organize the structure of your code to represent the overall problem into smaller chunks, where each chunk represents some kind of object. These self-contained objects are what we call in C++ a class. Those of you who've been with us before, you'll also be aware there is the keyword struct as well, but I will get into that later and explain the minor difference between the two of them. Classes represent reusable pieces of functionality. This is a really key point. One of the benefits of OOP is that you can offer some generic functionality and people can then use it in various ways. So for example, in the standard library you have stood string. So yes, you could use it to hold a piece of human readable text. That is one use for stood string, but you could equally use it to store some binary data. Stood string is just a class. It offers a set of functionality that you can reuse. A class owns its data and all usage occurs through function calls. So obviously there's nothing forcing you to do this. This is a design point really. Generally it's considered good design to ensure that everything in your class is not just accessible to the world, and they must interact with you by calling functions that you offer them, because this means that now you have complete control over the data you contain. Nobody can sort of directly access a piece of data and mutate it in an unexpected way and perhaps cause a crash, for example. And these function calls go to what are called member functions, and these operate on the data of the caller's instance. So obviously if I have the class stood string, you've designed the class, people now create instances of that class, and those are all separate, right? Each instance contains different data, or it may contain what is effectively the same data, but they don't know anything about each other. And a well-designed class should do or model one thing. There's a common concept, anti-pattern if you like, known as a God class, where you've created one object that's just doing way too much, and it harms readability, it harms maintainability. Ideally try and break down your problem into as small a piece as possible, within reason of course. If you decide that you could break a class down into 5 lines, and if you didn't do that it would be, say, 50 lines, it's probably not worth it. But there's obviously some give and take on this. And as I just said, actually, avoid packing too much functionality into your class. And finally, or not quite finally, testing and mocking is facilitated greatly by using OOP. So is anyone familiar with the terms testing, mocking? I mean, testing sounds very straightforward, I guess, but mocking, yeah. So one of the key features of OOP is that I can create a class that acts as a sort of interface, right? And then I might have derived classes that implement what it does, which then means when I'm testing, I can create fake classes or mock classes that will expect member functions to be called from the class that you're currently working on and give back some contrived data, but then I can write tests that validate if I put in X, I get out Y. And now you've written an implementation of your code structured as a class, and you've then got tests for it. Obviously, you can do this with straightforward functions. I could have a fairly simple function that takes two integers and adds them together. It would be obviously very easy to create a test for that. But when you're talking about concepts where you're now working on mutating sets of data, that's not as straightforward. It's got a state, right? There's an internal state to that class. And being able to mock allows you to obviously test out what will happen to the state of the class by faking the data it's going to get back. And if you were to use straight up functions, this would be more difficult because if a class is simply calling a function, there's no way to make it call a different function. It's going to call whatever the name of the function is. Whereas if it takes a class, you can derive from that class and then you could fake it or mock it. And taking an approach like test-driven development or behavior-driven development while utilizing these OOP concepts will actually drive your design. When you start thinking about how you want your class to function and how you're going to make it testable, so you're thinking, well, I'll need it to call this piece over here, maybe I'll have a car class, and but the car has wheels, right? But it's got to interact with the wheels in some way. Maybe it's got to tell them to turn on their axle. Well, if I'm going to test the car class, so I say, when I call steer, it calls the wheels to tell them to turn. Well, when I'm testing it, I'm not going to give it some actual wheels to turn because that's probably going to try and connect to some controller that's going to physically turn the car's wheels. So by using classes, I could give it a fake implementation of wheels, and all that implementation does is it checks when it gets called, well, did the car class actually tell me to rotate by 30 degrees, for example, if I tell it to steer 30 degrees. Key principles, and a lovely quote by Bjarne Stroustrup: if you think it's simple, then you have misunderstood the problem. And so, design recommendations. Classes represent objects, as I've said before, and they are primarily combined through inheritance. So, a class will inherit all of the data and the functionality of the other class, what we call the base, but I'll get to that in a second. Bear in mind that this does not let you just access everything inside the class you are inheriting from. That is the decision of the inheritee. So the class you inherit from dictates what you are allowed to see and what you are not allowed to see. But in terms of your overall size, so imagine your memory footprint, your class will be at least as big as the class you inherit from. And of course, if you add any additional data, it will be bigger by that much as well.
What if your class that you inherit from was a pure virtual class, a pure abstract class?
So if the class you inherit from, of course, has a 0 size, then you will start off with a 0 size as well. If you add data on top, then you will obviously now have, 0. It will be 0 plus whatever you add. So you should use this when you mentally think of the class you're designing as a kind of the one you want to inherit from. And a good example of this that I've put in here is an art student. So imagine you have a class called art student, which inherits from student. This makes sense because an art student is a kind of student, right? You could say that a tractor tyre is still a kind of tyre, right? That was a fly. And it makes sense because it's a kind of student. This is so small I can barely see it. Okay. Classes can inherit from multiple other classes. You're not restricted to one like in say Java. Obviously in Java you can only inherit from one concrete class. You can implement as many interfaces as you like in Java, but only one class. So in C++ you have no such restriction. You can inherit from as many as you want, as many classes as you want, and you can have different levels of inheritance visibility. This is something very important, which I will also get into later. And then composition. So You should use composition when the class has or contains something in that contains the other class, essentially. So I think I have an example here, don't I? A classroom contains a blackboard, right? You have a blackboard in your classroom, so my classroom class, as it were, could have a blackboard in it, and it might also have a string in it, to have the text that's written on a wall, who knows, right? But the point is that it's not a kind of blackboard, it just has one inside it. And prefer composition over inheritance. Generally prefer doing this. Using inheritance can get very, very complicated very quickly. There's a term called the diamond of death, which we won't cover in this lesson, but it will come up in later lessons. Composition should always be preferred. It's generally much, it leads to much better designs. I'm not saying that you should never use inheritance, that's obviously not true. But when you are modeling your objects, think about whether is it a kind of this thing or not. And it means designing classes objects that avoid having a kind of other type, as I said. And it heavily favours interfaces. Interfaces, we're not going to go over this lesson either. I expect I'll probably cover it next lesson. Interfaces are wonderful, but if you're just getting started, definitely don't worry about this concept for now. Okay, so the ROP Essentials. After you've constructed your instance of a class, so you say I want an instance of a std string, for example, right? No one here has created std string. I don't think there's any standard library implementers in here. But when you do create a class, and if you have a constructor, aim to make sure that after construction, the class is ready to go. Never have a special rule where you say, oh, well, you can construct an instance of my class, but then in order to actually use it, you need to call an extra member function that will do some initialization. You could do that, but it's generally, again, bad design, because somebody might simply forget to do that. And now they've violated the contract you've defined, and you could say, well, you've crashed because you forgot to do this, but generally just don't allow people to make these kind of mistakes. They create an instance of your class, they give it whatever parameters it needs, and it will do everything necessary to put itself in a usable state. Unlike regular functions, constructors can be overloaded. And there is a code example coming if you're wondering. Constructors can be overloaded, so I can have multiple constructors. So it lets the user choose the sort of ready for use state that they want in this way, right? I can have one, well, actually let me move the slides on. So for example, std string. There are multiple constructor overloads. You can default construct std string. Everyone here is familiar with std string at least, I hope. Yeah. Okay, so you can default construct std string. It's usable, but it's got nothing in it. But you know that because you default constructed it. It's part of the contract, as it were. If you ask it for its size, that's legal. It will tell you it's empty. If you try to access bytes from it, that's not going to work. But then, of course, if you do have some data ready to go, you can just construct it with that data straight away, right? You can construct a std string, give it whatever piece of text you want, and there you go. Once you've got that back, everything is ready to go. And now destructors. A destructor lets you execute your code just before cleanup. So that just before means that if you do create your own destructor, when it is called, all of the data in your class, all of the member functions in your class, you can call all of them. It's completely valid, right? Nothing has yet been destroyed. But after you return from your destructor, all of the memory that your class is taking up will be released. And any of the members you have in your class that are also classes will have their destructors called, and then they will be released. So it's a form of unwinding. So you can use a destructor to do any kind of special work just before the unwinding occurs. However, you should avoid defining your own custom destructor. Just if you need to do some kind of special work, so a good example is if you're trying to wrap a C library in a nice class, it's going to be easy and friendly to use. You'll probably have to do this because you'll have to call C functions in order to actually clean them up. But generally speaking, if you're working with pure C++ code, you generally should never need to actually have a custom destructor. Right, so on to the core concepts, and then we'll have some code. You can leverage ROP using either a struct or a class type. So it's a language keyword, you just write struct, and then whatever name you want to give your struct, or class, and whatever name you want to give your class. But, so not but. A struct or a class can contain functions, data, and any other type you like. So you can, as in, when I say types, you can have a struct, and then you can put a struct inside that struct, and a struct inside that struct. So you can, and structs and classes are what we call types, so you can even nest them. Functions and data sounds fairly straightforward, right? Yeah. And all of these elements can be public visibility. So this is obviously fairly simple, and the one we'll focus on today. Public visibility does what it says on the tin. Everyone and anyone can see. Yes, question. Is that a question? Oh. Everyone and anyone can see it, interact with it, modify it. Obviously, if it's your function, they can call it, doesn't matter who they are. And if it's data, they can also see it, do whatever they want to it. So usually, public visibility is what you do with your functions, not so much with your data. Possibly with types. So if you have a struct inside a struct, you might make that public.
There's a difference between structs and classes, but the
Okay.
real difference is that structs have a default of public, whereas classes have a default of private.
We are getting to that, yes. So there's protected visibility. So this one's slightly less straightforward, but actually it's not as bad as you think. It simply means that I am saying if somebody chooses to inherit from me, these are the things I will let them see. So if it's something that's not inheriting, it's just someone just using the class, they can't see it. But if they make their own class that inherits from mine, they will be allowed to see it and use it. And then finally there is private visibility, and this is saying that nobody can see this. This is mine and mine alone. Only I am going to be able to see, manage, and use this. There is one way to punch a hole in it. Sorry, question.
Can I mix structs and class in a way that I can make one inherit from the other?
Yes, absolutely. Yeah. But when you say mix them, do you mean nesting them?
No, for example, that I have a parent class and a child struct.
So if you nest it inside it, yeah. Tom, you don't need to exit. Just press the button.
Hello.
Okay. So private visibility literally says everything is yours. Now in C++, there is in fact a way to punch a hole in this, but we will get into that later. But you should generally, for the purposes of this lesson, private means no one can access it. And that's the hole I was talking about, yeah. Yeah, that's the hole punching I was talking about when I said, yeah. So now, struct and class. They offer utterly identical capabilities. There is nothing that you cannot do with a class that you can do with a struct and vice versa. Absolutely the same feature set. However, a struct will default all visibility to public, and a class defaults all visibility to private. And a constructor is always called, sorry I went a bit fast there, is everyone's clear on what this means, right? Public, I've explained public and private, and yeah, cool. So a constructor is always called when creating an instance. It may be an implicit constructor, so you always have you can get an implicit constructor. If you don't make one of your own, the compiler generally generates one, but there's always some kind of constructor getting called, whether or not it's one that you wrote yourself or not, i.e. one generated by the compiler.
Its default constructor is automatic.
Well, so you always have to, a constructor must be called, right? It must be called. So you could pass some arguments, and it'll call your constructor that takes arguments. Or they can pass no arguments, and if you have a default constructor, then it will obviously go to that, because that doesn't take any arguments. But the point is that something's got to get called. And a destructor is always called, as I said earlier, just before.
Sorry, would you mind to repeat the question? People from Alison would like
Oh, sorry. Yeah. What was the question again? I've forgotten. Who asked the question?
Who asked the last question?
Me, sorry.
What was your question?
My question was whether a struct, for example, can inherit from a class, or a class can inherit from a struct.
Oh yeah. Yes. The question was, can a class inherit from a struct, or a struct inherit from a class? And the answer was yes, they can. If you were talking about having a struct inside another struct, I'm not sure it will let you do it with the inner one, because you can declare it in there and not have it inherit. If you want to make it inherit, I suspect you may end up with an incomplete type error. It may just work though, I haven't tried.
The question would be whether they're internally represented by the same, represented in the same way. If they are like just two different types of the same.
Oh, so if I nest the declaration of one struct inside another, they're still completely independent. If I want to access it, I'll have to do like the name of the outer one, scope resolution operator, : is the scope, yeah. So : and then the inner one, but they have no actual relationship to each other, with the exception that the inner one can access private members of the outer one, but not vice versa. But again, this is getting a bit more complex. This is something I'll probably go into a bit later in the module. Yes, so anyway, destructor is always called just before the object is deleted. And again, there's no way of getting around it. When the object's about to die, some kind of destructor's got to run. Okay, so let's actually look at some code and a comparison. Don't worry too much if you can't read this. This is just a quick preview. As you can see, these are literally the exact same number of lines with the exact same code. The only difference is that we start out private up here, so these two are private because we didn't say anything. Then we say, okay, the next stuff's going to be public, declare all of those member functions, and then we've got an instance down here, but I'll get to that in a bit. And then the same thing here. We started out public, so I do all the functions first, then I switch it into private mode, and I declare the two strings, the first name and last name. So let's do a line-by-line deconstruction of this.
Can't see if you open the YouTube string.
Yeah, if you can't see, there's a YouTube, but this is going to be larger anyway. Oh, yeah, turn the lights down. Is there control here? Oh, this has got a laser. Ah, even better, right.
Is that too dark?
Right. So, first of all, we use the struct keyword, and we've decided to call it student. So this is the name by which other programmers, or yourself, will actually create an instance of the object with. And obviously we open the curly brace to begin the declaration of the class. I'll use the word class because, again, there's no real difference. I happen to have chosen struct here, just for simplicity, but I'll use the word class. Okay, so we've got our private keyword. We're not going to get into what's here yet. So we're going to have our private keyword, and we'll declare a string for the student's first name and a string for the student's last name. Now for the constructor. As you know, the constructor has the exact same name as the class itself. This is a requirement, and you may note it has no return type. Constructors are somewhat like a function, but they do not have a return type. It must have the name of the constructor must be whatever the struct class name is, and it must not have any return type. And it can take arguments just like a function. So we take a string, which I'm calling first name. Technically speaking, this makes life a little bit harder because obviously this is now the same as this, but I'll show you why that's okay in a second. And of course, a string for the last name. I've broken this onto 2 lines to make it easier to read, but essentially you can put it all on 1 line. C++ does not care about line breaks. And then we have this operator here, which begins the initializer list. So now we're saying, okay, I want to tell you what to do to initialize my data. So of course we have first name, which is this thing here. Don't worry too much about the std move. I just added this in case anyone was sort of leaping ahead and curious about extra C++ stuff. The std move is an optimization. You could just not have it. But we have first name, which refers to this one.
Why not just use an initializer list?
That is an initializer.
That is an initializer. Anyway.
So but I mean, one way that you could do so was just to have first name and then put like the private data members in between brackets. Like what first name, last name, curly braces. Do you get the picture I'm trying to?
So the most efficient way to initialize data members.
Can you repeat the question?
Sorry, well, the statement was I could have just used an initializer list, but this is an initializer with the colon.
So it's moving the parameter called first name into the member called first name.
Yeah, I know. So what I was saying is, why not just use the initializer list?
What syntax do you mean by that?
So you'd have like first name,
So I have first name. Yeah.
parentheses, first name. You wouldn't need a stood move.
No, that's less efficient because that would invoke the copy constructor.
Yeah, so he is using a bit after the colon is the member initialized list.
Yeah.
Constructor.
So
They're not copying.
sorry,
They're not copying.
In this list,
more efficient. Again, so you don't need the stood move. It's just less efficient.
That's the point I was saying. Yeah.
You don't need it. It's just less efficient. If you don't use stood move, it is less efficient. If you do use it, it is more efficient. Potentially, yes. Optimizers are clever, but the point is that generally speaking, this is accepted. So we have the first name referring to this one down here. We open the curly brace to initialize it. You can also use parentheses if you're familiar with the older style of C++. You don't have to use these curly braces. You can use parentheses. Again, the stood move is optional, just an optimization. And this first name is referring to the parameter that the user is going to give you. And then, of course, we're done. Close it off, add a comma, and initialize last name in exactly the same way. And then finally, we have no actual code that we want to run, so we just have an empty body. If you did want to run some code, like print to the console maybe for debugging, you would put it between these two curly braces, just like you would for a normal function. In my case, I have nothing to do, so it's empty, but I have to put it there. You can't not put it there, unless you're using a declaration. But if it was just a declaration, then these two lines would actually just be gone. It would only be that. So next we have a member function. I'm going to take this keyword by keyword. Some of these I again added just for those who are curious about more advanced C++ features. So we have a member function called first name, which takes no arguments. It returns a reference to a const string. It is const accessible, so that means if you have a const instance of student, you are allowed to call it because I've qualified it as const. These two pieces, the ampersand and the no except, these are more advanced. If you're curious, you can look up ref qualifiers and the no except keyword, obviously. But these are just more advanced. The ref qualifier, if you're really curious, but don't worry about it. Go on.
Can you have stood string ampersand const first name?
Stood string ampersand. So the question was, could you have stood string ampersand const first name? Yes, that's just a different place for the const. It means the same thing. He's waving his East const wristband around now. Okay. Yes, it would mean the same thing. But this is an L value ref qualifier, which means that you have to have a L value version of student. If you don't know what that means, do not worry. And no except means you're guaranteeing this does not throw exceptions.
The const, like after the function,
That
means that you can't modify stuff in the body.
Yes, it also restricts what the function can do. So by putting this const at the end, it means anyone using your class can access it from. Sorry.
You're just going to use it for returns. That's allowed.
No, it's so that if I have a const student, right, I should still be able to read the first name, right? In order to make that possible, this const qualifier says that you are allowed to call this function.
But not to modify stuff.
Yeah, so it means I return this as const, so you can't modify it. Additionally, though, inside my function body, I'm not allowed to modify my own instance. If I would have to create a separate overload to do that. And it's fairly simple. We return first name, which is no except is saying I guarantee I will not throw exceptions, and if you do throw exceptions anyway, your program will terminate.
So how many of those ampersands can you use? Can you use more than one?
These? No, you can have either a single one or a double.
So one when you have two things related to the function.
No, these are called ref qualifiers. Do not worry about these. I just threw them in case anyone's leaping ahead and curious about.
Two things, you have to use that.
You don't have to use it. No, it's optional. The ampersand and the no except are completely optional. You could have stopped at const and started the code.
You could have stopped it.
You could have just put a curly brace straight after this const, the second const for those watching the video. These two are just being fancy. And we return first name, which is this thing down here. But it returns a reference to it. They can't, and it's const, so they can't modify it.
I think my question was how many arguments you have after the first name, you know, the brackets. Yeah? So you have const and no except. Could you have more of the options there?
You mean more decoration?
Yeah.
I can't think of any off the top of my head. I'm sure there's a couple more you could squeeze in if you want to be really, really silly. Yes, I'm sure C++ has something. But the key point here is the ones that are necessary, okay, is obviously the return type. You've got to have a return type. The only one that's necessary really here is just this const. The rest of it can go away. The ampersand and the no except can go away. Don't need.
Would you recommend coding in this manner? Because I mean, you could just write that as stud string first name without any of the constant and
Yes,
no
that's entirely true. But if you do that, then you're going to make a copy of it every time. Which I don't necessarily want to copy the student's first name every time I want to look at their first name. So yes, you could, but it's going to be less efficient because now it's got to copy the memory every time someone calls first name. Right. And then, of course, we close the function, so we have an opener here, and we close it here. Fairly simple. And then, again, exact same thing, but it's the last name. Fairly straightforward. And now let's have set name. So it returns nothing. I called it set name. It's a member function. It takes a reference to a constant string for the first name, and it takes a reference to a constant string for the last name. So if you want to give them a new name, basically. And now you see that in order to access our instance, we use the special this language keyword. So it just so happens in C++ that this keyword is a pointer, and so you have to use the arrow operator on it. But this represents the user's instance of our class, or whatever instance of our class it happens to be, and we're of course setting it to first name. And then, of course, we're setting this one to last name, which is the two parameters here. Obviously, if I didn't write this, and I just had first name equals first name, it would think I was setting this thing to itself and this thing to itself. Yes?
The first two functions that you wrote, first name and last name, they are the closest that you can get, like, to Python attributes. Is it?
What's what? Sorry, a bit louder.
I mean, from other languages, you have this concept that, for example, objects can hold attributes, which are not member functions, but you can still, if they are public, you can still call them and return the value of that attribute.
Are you thinking of static?
I think you're thinking of something like properties in C#, right?
Are you maybe thinking of like annotations in Java?
Attributes in fact,
Yeah, that's like, is that like reflection kind of metadata? We don't quite have something like that in C++. We don't quite have something. So the original question was whether we could have attributes on these things. Strictly speaking, C++ does have a concept of attributes. You can use double square brackets, and there's a set of known attributes, but they're generally for omitting compiler warnings if someone does something silly. So for example, there's an attribute you can put on functions which is called no discard, and if you do put it on there, the compiler will check if anyone calls your function and throws away what you return to them, and it just emits a compiler warning. So we do have that, but there's only a small set of well-defined ones, and they're generally just for stopping people doing stupid stuff.
They're also good for mentioning if code has become deprecated or depreciated.
And what's become deprecated?
The codes, like you could use the double square brackets and like to mention that code has become deprecated.
Yes, there is also a deprecated attribute. So I can mark a function as deprecated, and if anyone uses it, the compiler will throw a warning at them and say, oh, someone said this was deprecated, you probably shouldn't be using it. But again, these are all just, the attributes we're talking about here are just allowing programmers to stick more information in their code to help other programmers. There's nothing the language particularly cares about, except for no return. That's a special one.
Question from the internet.
Yes.
Don't you normally use naming convention for members variable, prefixing them with m underscore or just m?
Yeah, the m underscore is a common idiom. Personally, I don't. Many people do. It's a matter of style, obviously. East const versus west const. Yes, but you can choose to. Wrong button again. You can choose to decorate your member variables with an M underscore. I mean, it's not bad. It's fine. The real thing is be consistent. Make sure that when anyone's dealing with your code, you apply a consistent style. It's up to you to decide what that style should be. And then, of course, we close off the function, and then finally we close off the class. And then just to demonstrate that you can do this, you generally shouldn't, but you can. Usually, you would close off the class and then immediately have a semicolon. And you must have that semicolon. The reason you must have it is because you are allowed to do this here. We are creating an instance of our student class. The name of the variable is a student, and we're initializing it with John for the first name and Smith for the last name. And you can then go ahead and use that. So if I stuck this in a header file, I would end up with a global variable called a student.
I'm slightly confused on the set name. Are you setting, if you call set name with a student,
No, I can't call it with a. I could do a student dot set name.
yeah.
Yeah.
And then in the brackets say Mike Smith. Now,
Yeah.
are you setting the first name and the last name? Which one is it? Are you setting Mike in student?
Yeah, these two will get overwritten. So if I did a student dot set name Mike Smith, this is going to return a reference to Mike, and that's going to return a reference to
Yeah,
Smith.
but in the set name, you're going to replace Mike.
Yes, these get
John,
overwritten.
John with the Mike, not the Mike with the John.
Correct.
Yeah.
Yeah. So these are the arguments going in, and I overwrite what I've already got in my data here. Sorry? Yeah, so the question was if we were to call set name on the a student variable, so a underscore student dot set name, somewhere else in the code obviously, you can't just do it on that line there. Yes, it would obviously then overwrite John Smith with, if we pass Mike Smith to set name, then you turn it into Mike Smith. Right, now let's talk about inheritance. And again, another great quote that I found that I loved. C++, an octopus made by nailing extra legs onto a dog.
In constructor, you pass by value and move the value into the member variables. Shouldn't you do the same in the set name? Or do you have
that's a yes. So that's a valid point, but unfortunately not correct, not relevant in this case, rather. So the reason that we don't use stood move here, they were asking about that, right? Stood move, basically. Why we don't do it the same way?
yes. The question was, in the constructor, you pass value and move the value into the member variables. Shouldn't you do the same in the set name?
Right, yeah, better. So the answer is arguably yes, you should, but I just wanted to, I don't know, give some flavour to it and demonstrate what you can do. Yeah, these are obviously const references, so I can't stood move them. I mean, you could write stood move. It would compile fine if I did, but it would do absolutely nothing. These are const, and they are references. You can't move something that's const. You have to copy from it. So yes, I could make these go by value, and arguably I should, but just for texture, I thought I'd just vary it, right? Okay.
Question, sorry.
Yes.
So earlier on you showed the class and the struct, and are both like the same. And you've also like you created an object called a student, right? So everything was the same. Now, if you were to like try to create instances of like the class and the struct by using a student, wouldn't that cause a runtime issue problem? Because the compiler wouldn't know which one to go for.
Do you mean on the previous? Let me just go to it. Hold on. Do you mean?
You had like the class.
Do you mean this one?
Yeah, that's right. Now, if you were to call both of them, like say in your main.
No, hold on. I've got you. So the question was, would the code on the current slide be legal or illegal? Yeah, if you stuck these in the same project or file, it's completely illegal because you can't have two definitions of a type with the same name. This was presented as if they exist in separate universes. So imagine this is in one universe, the structure's in one universe, this is in another universe. They don't see each other. Right.
Or you could just put like student underscore, and that would be slightly different then.
Well, the problem is I can't have, again, it's illegal to have struct student in one place and then class student in another because I'm now redefining the type.
Oh, okay.
So that's completely illegal. Now, if I gave it a different name, so I called this student 2 or something, so we had struct student class student 2, then that would be slightly different. But because it's illegal, I can't have two different types of student. So I can't have student 2 and then class student 2. So I can't have student 2 and then class student 2. So I can't have student 2 and then class student 2. So I can't have student 2 and then class student 2. So I can't have student 2 and then class student 2. So I can't have student 2 and then class student 2. So I can't have student 2 and then class student 2. So I can't have student 2 and then class student 2. So I can't have student 2 and then class student 2. So I can't have student 2 and then class student 2. So I can't have student 2 and then class student 2. So I can't have student 2 and then class student 2. So I can't have student 2 and then class student 2. So I can't have student 2 and then class student 2. So I can't have student 2 and then class student 2. So I can't have student 2 and then class student 2. So I can't have student 2 and then class student 2. So I can't then the types would be fine, but then these would not be if they were in the same scope, because obviously a student would already exist, so you wouldn't be allowed to have another a student of a different type. But you could obviously have b student or whatever. Okay, so inheritance.
Can you just go back to the slide just for 1 moment?
Yeah, sure. I mean, I'm going to upload these later to the internet if you want them. What's the question?
I've recently heard about a concept of shadowing. I don't know.
Yes. So that's why I said the same scope. So if you introduced again different types still, if you had a different type, but you had this in a scope, then this would end up shadowing that. But again, the type names would have to be different. So it could be struct student, class, another student, whatever. And then if this was, say, global, and then you had this in the scope of, I don't know, some function, then yes, this would then be okay because it would hide the outer one.
So for the variable name, it's okay, but
not for the type. Correct. You can separate them either by nesting them. So I could put this one, the class student, for example, I could stick it in a namespace, or I could stick it in another class. I could have a class outside of it. That would obviously then change its scope and hide it effectively, separate it. Okay, so let's look at inheritance. As I said before, you should use inheritance when this thing is a kind of another thing that already exists. The class that we inherit from is known as the base class. Does that make sense to everyone? The idea of a base, right? So the thing we're going to inherit from is the base. And again, as I touched on before, an inheriting class can access all of the public or protected things in the base class. When I say things, it's what I mentioned earlier: the member functions, the data. So, for example, the stood strings in the first name and last name; those are data, right? So, being public or protected, I would be able to access them in my inheriting class, my derived class, right? The class that's inheriting is the derived one. It's derived from the other. Bear in mind that your base might have its own bases, because you can keep on inheriting, right? I could have A, B, C, D, and they're just like D inherits from C, C inherits from B, B inherits from A. So A would be the sort of true base, because A doesn't inherit from anything. And B's base would be A, but C's base would be B. And as far as C is concerned, B is its base, but obviously there's also A under it. And that can get a little bit complex, as I'll show you in a second, because the type of inheritance you can do public, protected, or private inheritance as well, can affect what can be seen down that chain of inheritance. As I've just said, yes, it can be public, protected, or private. And public exposes everything that is also public in the base to people who use our class. So if someone's just not using it in the same way that I would use stood string, right? I don't inherit from stood string. You can do that, never ever do that. Or any standard library classes for that matter. But anyway, yes, public inheritance will expose us to everything that is also public in the base to people using the class. And anything that is protected will also be visible to someone who chooses to inherit from us. So in that A, B, C concept, if B inherits from A and C inherits from B, so imagine you've got A at the bottom as the base and C as the most derived, then C will be able to see everything in A, if we use public all the way down, or protected. So when we do use protected, now users can't see this inheritance. So for example, given the student and art student example, imagine your student has that first name and last name, and your art student maybe has some paintings, and actually I'll have an example of this in a second. With the protected inheritance, art student can see the protected fields of that one, and then I can have maybe like professional art student, right, coming from art student. And if the inheritance was protected all the way down, then every class can see, the most derived class can see everything in the most base class. Confusing? Yeah, it will be less confusing with the code, I hope.
But vice versa, not necessarily.
What do you mean?
The base class cannot necessarily see the derived class.
So a base class can never ever see something in the derived because it simply doesn't know about the derived, right? When I derive from a class, I know about its existence, I know about the existence of my base, but when I wrote my base, it can't know anything about the existence of the thing that's derived. It hasn't come yet. And private completely hides the base from everyone and everything. Nobody knows you even inherited from it, really. The compiler does, because it has to know how much memory to allocate. But in terms of other programmers, private inheritance effectively just disappears away the thing you're inheriting from view. However, we will focus purely on public inheritance. It's the most common form of inheritance, and it's the most simple to understand, and it's generally what you want to use. It's generally what you want to do. Protected, there are rare use cases. Private, some for optimization purposes, but they're way up the chain of advancement, and I would just say focus on public. It's very easy to understand. And a class, as I said before, can inherit from multiple other classes, but for reasons that we'll get into in another lesson, you generally don't want to be doing this. There's one exception which we'll get into with interfaces, but for now, prefer to avoid inheriting from multiple other classes, or just prefer composition. So now for the example. So we've got our student class, which I showed you earlier, same as ever. And now we're going to have a new class. It's our art student class. And we're saying that it's going to inherit from student, so the colon is the token that the compiler looks for to see, okay, now you're going to start saying what you inherit from. This inherits from nothing, so consequently it doesn't have one. So student does not have that well, you can't put the colon there essentially. Anyway, art student, the separator, and we say that we will publicly inherit from student. Now, because it's a struct, does anyone know what I'm about to say about this keyword, this public keyword? It's not precisely, it's not necessary, it's redundant. It doesn't do any harm, but it serves no purpose. Now, if I use class art student, I would need it then. But in this case, it's just redundant. And again, we're going to declare some private data members. So we're going to have a vector of paintings that the art student has done. We don't know what painting actually is. For the purposes of this, it's exposition. It's some type that represents a painting. So the first piece is we're using, this is where it gets very interesting, student scope resolution operator, : student. Does anyone have a guess what that might be doing, perhaps? If you know, then don't worry about it.
Affects a container, which is private, and I imagine you'll populate that with something that's of type painting.
No.
So what about the line with the using?
The using statement is what I'm going to.
So is that what you were thinking?
Yeah. Just ask
Oh, so what you're doing is that you are taking the constructor from the.
Oh, you knew, didn't you? You knew.
You're taking the constructor from the
So,
student class.
Yes. So what this is doing is this is a language keyword. Again, it's a special C++ keyword, and we're saying we want to use the constructors that are defined in student. We don't need to do this, and you in fact can't do this for first name and last name. You can't, and it's not necessary. These are public, so these are automatically visible. Constructors are special. When you inherit, it's up to you to determine what constructors you want to bring forward into your derived type. You don't have to do it this way. I'll show you an alternative way in a few minutes. But essentially, we're saying, please bring the constructors of student into our class. So if somebody wants to initialize us, it will just recycle this constructor right here on the left-hand side.
But if you didn't do that, it would just go back to the default constructor?
If you didn't do it, it wouldn't compile.
Oh, okay.
If you just had nothing, so if you got rid of this line entirely and had nothing, it wouldn't compile. Because the reason why it wouldn't compile is because there is no default constructor here.
Okay.
So if you don't do anything, you get a default constructor. But then obviously in order to construct, so the compiler will say, okay, you haven't said anything about constructors, we'll do a default constructor. Okay? It will check if you have default constructible members. Well, yes you do, vector is happy to default construct, so that check passes. But then it will check student, because you inherit from it, and then it goes to student and says, well, does student have a default constructor? Well, no it doesn't, because you have one that takes arguments, which suppressed it, so now it'll say, well, can't compile, sorry. So, yes?
So when it says using, does that imply that it's a constructor, or does it just say that you know about this function from student?
So we're saying to the compiler, I want to use inside the student class. So this represents the type.
Yeah.
This is the scope resolution operator. So we're saying something inside it, and then that something inside it is of course the constructor.
So, but it wouldn't have to be a new constructor. It could be a function that did something else entirely.
No, you can only use this particular
Okay.
feature for constructors.
Okay.
And the inheritance one says they want to use its members.
So you don't know. You will not. Do not. You cannot use
No, I
using
understand the one
for
about
members.
The inheritance, which are inherited from students, means that you want to use students, members, like function members and data members. That's what it means, right? Inheritance.
Yeah. So this will publicly expose everything in student that is also public.
Yeah, but not the constructor.
But the constructor is special. Yeah, the constructor is special. But yes. So go on.
Instead of using, there's this really long-winded way where you will, in the constructor, you would have like the class that you're inherited from and all of its data members in parentheses.
Yes, I have any.
And then you would have the class that you are about to create and all of its.
Yes, there is an example coming. Yes.
And it's really complicated to look at.
It's not that nice though. But anyway, so we're on to the member functions. So because we inherited publicly, we just get these first name and last name for free. Anyone can instantiate an art student class and just use first name and last name, so that saves us writing more code. But we obviously want to give access to the paintings, so again we return a const reference to stood vector of painting. I called it paintings to get them. It's const accessible, and again L value ref qualified and no except, but don't worry about those two things. And I just return obviously paintings, which obviously then returns the reference. Close it off. We have an add painting. And again, for texture, this is by value. So we will in place back, similar to pushback, basically, does effectively the same thing. And we stood move the painting object into the vector. Again, just an optimization. You don't have to use stood move, but it's faster if you do. And close it off. And then finally, we close off the struct. That's it, done. Anyone, this is ready to use. Yes, question?
Now we don't have the member variables first name and last name defined, I think. Because,
We don't need to. We inherit from student.
but I mean they are private in student.
Correct. So we cannot access them in our art student except by calling first name or last name. So when we inherit from student, I could make a call to first name or last name in the body of this and in the body of this. It'll work just fine. But I can't access these directly now. I cannot directly access them because they're private. If this was protected, then I could directly access the two of them. But they're not, they're private, so my only options are this function or this function.
What does mean access in that context? Does it mean I could call student scope operator first name and then retrieve the value?
So it's even simpler than that. So when you inherit from a class, anything that's public or protected, it's just as if you put it in here, right? Even though I didn't physically write those functions in this file, if you like, because I've written this bit here, they're just exposed. So I can directly just call first name or last name here. I don't need to do dot first name or anything fancy. I can just write first name, brackets, and that will work fine. Because they're in my scope, I'm inheriting from it, so it's as if they are physically part of my art student class.
That's why what I'm confusing, because right now it is you are in an instance, or you create a variable.
This defines what will happen with an instance. So somebody will then create an instance of art student, somewhere else in main, in some function of theirs, right? I'm just declaring the existence of the class here, and it happens that I've also defined what the functions do. So the bodies of these functions operate on an instance, right, that somebody will construct of this. Yeah? So these are both functions. These are both functions.
Yes, I understand that. I just don't understand when you call the first name and the last name function, and you create this variable, first name and last name, then there is nothing defined in art student that you would return that value to.
Yes, there is, because even though art student can't see these, they do exist.
Okay.
So an instance of art student, again, as I was saying earlier, the size of this derived class will be this plus this plus this. That will be the subtotal size, right? Because there'll be memory for these two and memory for this. The private visibility keyword just says that this guy isn't allowed to access it. He still has it, he's just not allowed to touch it.
That means this arrow trick would not work.
Yes, correct. What would happen is the compiler would actually refuse to compile it. It would give you an error saying, you're not allowed to do this, mate. Although in more professional terms than you're not allowed to do this, mate. But again, it's a language level restriction, right? The compiler's just going, no, violation. Okay, so let's touch on some somewhat less simple inheritance. Basically doing the same as we just did before, but in a DIY kind of sense. So again, we have our art student, which inherits publicly from student, from this guy. Again, we're going to have our private member of paintings. But now we're going to do our own constructor. We're not going to use that simple using statement. We're going to do it manually. It's going to do exactly the same thing as what you just saw previously. This code does exactly the same thing. That's the important sort of thing to note. But I'm manually doing it myself now in code. So I have two arguments for my constructor, which is first name and last name. And that's obviously because this is going to want a first name and a last name. Unless I was going to be silly and just, pass it that twice. But that's not really what you want, is it? And actually, let's take a painting as well. So we can take the name for this guy, for the base class, so we can make the base class happy. And you know what, just for optimization purposes, maybe the student's done a painting already, so we'll just optimize and let you throw that in there when you construct it. So the first thing we do is we need to dispatch to the constructor of the base. And in order to do that, we simply write student, after the colon, again, this initializer list. So after the initializer list declaration, student, curly brace, std move first name, comma, because obviously this takes two arguments. Don't forget it takes a first name and a last name. So we pass the first name, again, do not worry about std move, and we pass the last name. Then we close off the curly brace. So that's it. This will just call the constructor for student, and then we're ready to go. And now I decided, you know what, let's have a body of code to run as well. So this enters the body of code for the constructor, just like you would enter the body of code for any normal function you'd ever write, right? Yeah. And we're going to again stick this first painting into the paintings vector down here, and we're done. So whenever someone creates an instance of art student, they must, similar to this, right? So this is creating an instance down here. The variable is called a student. In order to create an instance of art student, you could have John Smith, and then an instance of some painting, and then it will happily construct. And then of course we've got our usual, the member function that will let you read the paintings, and of course it's const, so you can't modify it. We've got add painting, which I'm now putting in here again by value, a new painting, and it will shove that in. So you can have one painting initially, and then, well, you must have one painting initially, and then you can add more later, should you wish. Yeah, sorry, question.
But the painting type is not defined now in this.
Correct, yeah. I mean, the painting is exposition. It's not relevant to the
But
design.
I mean, can you define like implicitly a type by, for example, creating the vector this way?
No. So pretend that up here somewhere the painting class exists. So imagine above this we actually said what it is, or you can do something called forward declaration as well. But in this case that would fail horribly because we're trying to actually trying to use it. So just pretend there's a painting class up here that exists.
Std move is a member of the utility library.
The utility header, yes, that's correct.
You use the move twice, once in the art student, and then you use it again student. Is that a mistake?
Where? Sorry.
Move, the STD move, you use it twice.
Yeah, we're moving first names. It's by value. So we move construct into this parameter over here.
It's already for him. He
Sorry?
hasn't been there. The the struct student.
Yeah, so this is why I said don't worry about std move. So this is a complexity because this is an L value. Okay, even though we moved it once,
Yeah.
it's then got to be moved again. These are value category rules. They're not part of this lesson and they get horribly complex. But
So we do have to do that this time.
you don't have to do this stuff. These are all optimizations. Ignore std move. It's purely an optimization for the purposes of this.
If we use the struct student, do we have to like use it again? The one that is a friend of?
You can.
So for the most optimal code, this is absolutely correct. But you don't have to do it. It'll just be less optimal. And again, don't worry about it about std move. Okay, so composition. This is obviously one of the quickest slides I've got. It's simple. I think everyone's going to get this. Class X has a class Y. So stick a string in your class. Congratulations, you've done composition. You're amazing. And just an example, right? Let's make a class called Blackboard. Stick a string in it for the text of the blackboard. Great, you've done composition. Have some declarations. So let's get into these real quick. So as you saw before, when I had the student, an art student, the functions had a definition, right? You could see the code that they would execute. But in this particular case, I've decided I'm not going to do that. I'm going to do it later. So I have to declare the function still. So for example, getText will return a const reference to a std string, and it is const accessible. But I'm not going to tell you what it does. I'm not going to do that here. I can do that later in a separate file. So I can put this in my header file, and I can define what it does separately in a CPP file. And then similarly, I've got a setText function. I can give it a string of text. It returns nothing. And again, I'm not telling you what it does, but you know it exists, so you can at least call it. And then the same, there's one to render the text on the screen or whatever. Again, returns void. And we close that off with the obligatory closing brace and semicolon. And then let's have classroom. Great, we've done composition again. Yes, sorry, question.
Why would you prefer endPlaceBack as opposed to pushback?
So I tend to use endPlaceBack preferentially. In the examples I gave there, there's absolutely no benefit because the object is already constructed. The purpose of endPlaceBack is when you don't have the object constructed yet. So imagine I want to construct a std string, yeah, in a vector. If I use endPlaceBack and I don't have a string yet, I've just got, say, a char star, an array of bytes, for example, right? If I use endPlaceBack, it does something called perfect forwarding. So it will allocate the memory inside the vector for the string, and then just directly run the constructor on that memory with my argument. Whereas if I use pushback, I have to have an instance of, say, std string, and then what the class will do rather is it will take my already constructed std string, and if I use std move, it will just construct the one inside with the instance that I'm passing. So you can use move construction or copy construction, but it's obviously annoying, so I've got to construct it once, and then it's going to have to run the constructor of the same type again inside the code of the vector itself. So endPlaceBack can be more efficient when you've got the arguments ready to go and you haven't constructed yet. In that case, I'd already constructed one, so it didn't really do anything. But it doesn't make you worse off either. Also, you can't use endPlaceBack for trivial types. It only works for types with an actual explicit. Is it an explicit constructor, Tristan? You can't use endPlaceBack unless it's got is it explicit constructor of some kind? What was it? What's the restriction? There's a restriction on it, basically.
Why explicit constructor? You use a constructor that takes more than
Sorry,
one.
not the explicit keyword. Sorry. What was it?
Pushback will only consider implicit constructors. endPlaceBack will consider explicit and implicit.
Well, it doesn't work like you can't endPlaceBack can you?
Can't endPlaceBack aggregates.
Yeah, that's the one. Can't endPlaceBack aggregates. Thank you. But that's again advanced stuff. Don't worry about it. Right. So we've now decided we will give the code body. So again, set text, render text. Is anyone remotely confused by that? That's composition. Very simple. Simple function, right? Calls the members of this. Easy enough. Yeah. Okay. All right, on to ROP rules in C++, and again another great quote. C makes it easy to shoot yourself in the foot. C++ makes it harder, but when you do, it blows your whole leg off. Okay, so the constructor rules. This is stuff you need to know so that it doesn't catch you out. But to be honest, this is one of those things that you'll probably quickly agree with me is actually quite unpleasant because you do have a fair bit to memorize. But it's what it is. So let's crack on and get into it. So if you don't define a constructor, you get a default one. Asterisk. Providing all of your data members and bases have a default constructor. So this isn't actually that complex to understand. If you don't write any constructor, you're saying, okay, well, I'm going to just try and default construct me. Is everyone clear on what default construction means?
Yes.
Yes.
When you provide one, you get the default one.
Yes,
So
Scott.
it's without arguments, right?
Precisely, it means without arguments. Default construction is when you're constructing the object and you have no arguments for it. You just want it to make itself exist and be usable.
You initialize the data.
Yes. So the caveat to that is that you don't define any constructors, you get the default one, doesn't take any arguments, but all of the data that you stick in your class, like, I stick some std strings in my class, std vectors, right? They must also have a default constructor, which is fine if it's std string and std vector. They do have default constructors, that's not a problem. But everything I inherit from, as well, must also have a default constructor. So the moment that any of those things fail that check, does the base class have a default constructor? Yes. Do any data members have one? Yes. Okay, we're fine. If the answer is no to any of them, that's it. It will not generate a default constructor. Yes.
So how could I break that rule? Is it that maybe in the chain of inheritance I have one single member where I haven't used the using keyword or defined
Yeah, that's one example. Yeah. Or the class, that base class simply didn't have a default constructor, or it had a member.
Doesn't the child class look automatically if there's no constructor defined for the?
Well, the compiler has to check the whole chain. Yeah, the compiler looks into it.
The default constructor would be always the last defined one that I can find, and if not, then the default.
Sorry,
Let's say we have like a chain of like 2, 3, 4 classes.
Yes.
And only the first one has explicitly constructor.
So the base one has. Oh, you mean the base? The most base has a constructor taking arguments, and that's it. Yeah. Then that will suppress the default constructor for the next one up, which would then suppress it for the next one up, the next one up, and the next one up.
So every one of those will still have the same constructor of the base class.
Only if they said using, or reproduce what it does, as I showed earlier. If they don't do anything, then it probably won't compile, basically.
The default constructors will be 0 or empty. What you define strings or vectors or.
I mean, the state of default construction depends on what the thing is. So yes, if it was std strings, if it was std strings, then they're empty. If it's std vector, they're empty. It just depends what. If you make your own types, it means whatever you want it to mean. Defining your own constructor suppresses the default constructor. Now, of course, this doesn't matter to you much if you explicitly define your own default constructor. If I have student, brackets, and nothing, no arguments, that is a default constructor, but it's my own default constructor. There's a difference between the automatically generated one that the compiler creates for you and doing one myself, right? You're free to do that. It's okay to do that. But if you do one that takes arguments, one or more.
What if you ask the equal default?
I'm getting to that.
Okay.
I am getting to that.
Right.
Yes, defining your own constructor, so it takes one or more arguments, will suppress the default constructor. That's it, it's saying, okay, you probably don't want one. You can bring it back, and we'll get into that shortly. Actually, the next bullet point, in fact. T equals default. Very simple. So T is the name of our class, so if it was called student, you'd write student, not T. If it was art student, you'd write art student. And equals default is telling the compiler, I want to re-expose this. If you were to write this, and you hadn't defined any constructors yet, this would be fine. It would not actually do anything useful, but it would work fine. You can tell it to explicitly default the constructor even if it was going to generate one anyway. It's quite happy to let you do that. It won't break anything. But, again, whilst you can write this line of code in your source, if, as I said before, to this bullet point here, any of your data members or bases are not default constructible, this does nothing. And you'll just be really, really confused. Because even though you've written this, you're like, okay, I said this was default constructible. The compiler's just going to error out and say, no, your type's not default constructible. I think recent versions of GCC may have got a bit more helpful and said to you, by the way, you wrote this, but unfortunately, I can't do anything with it. I know for a fact in older versions, it wouldn't tell you, it wouldn't help you out. You'd just be sitting there like, well, I told it it's default, but in fact it couldn't because this was, you know, a data member or a base class was preventing it from actually generating it. So there are also two special constructors that the compiler, again asterisk, will generate. We have the copy constructor. So again, T is the class name. You substitute T for student or art student, right? Blackboard, whatever name you call it. And this constructor takes a const reference to its own type so that it can copy from it. And then there's the move constructor. Again, don't worry too much about this one. This is an optimization. This one's fairly crucial, obviously, if I want to copy it. But yes, question?
What's faster, move or copy?
Move is generally faster than copy. It depends is the key answer. For example, std array has a move constructor, move assignment operator, but generally it won't actually gain you a benefit, depending on the type inside it.
Move is never slower and sometimes faster.
When did the $ampersand syntax start being used?
C++ 11.
Because C++98 didn't have that, right?
No, absolutely not. It was created with C++ 11.
And what does it do? Like, what's the difference now?
It's essentially a new value. It's a new value category, right? So we had the value of references and pointers, the category of references and pointers, and now we've added a new one which we call R value references. So this can represent something that's a pure R value expression, or X values as well.
The 1% means that it takes a move.
It means it takes, it's a restriction on the type you're allowed to pass. So this const tref can take anything. It can take a named variable, it can take an unnamed one, what we call a temporary, and that's fine. This one can only take temporaries, something that's movable, something you're allowed to move from. But don't worry about this one too much. Again, don't worry about the move. Copy constructor, that's the bare minimum you need to worry about. And again, if one or more of your data members or base classes lack one or both of these, then the respective one will be suppressed and your class will not be copyable and or movable. So if you have a data member that's not copyable, that's it. Your class the compiler cannot generate a copy constructor for you. And obviously, generally speaking, it's nice if you let the compiler generate these for you, which means don't write the code for them yourself. Probably at this stage you have no idea how anyway. But when you do, avoid doing it unless you need to.
But if you were exercising copy control, then you would have to write some type of code. Like they say when you're building a class, it's good to have some form of copy control.
I mean, nowadays we can just explicitly delete the copy constructor if you don't want to let someone copy it, and just have a move only type. That's how unique pointer works. So it depends what you're doing. And as I probably hinted, you can define any of this stuff yourself. You know, I don't have to use equals default. I can give it a body, curly braces, write some code, so my default constructor can, I don't know, print hello to the screen, whatever I want. And the same applies to these. Even though they are considered special insofar as the compiler can auto-generate them. So it can auto-generate the default constructor, it can auto-generate these two constructors as well. But it doesn't care. You can define them yourself if you wish. But again, don't unless you need to.
Defining your own constructor doesn't necessarily suppress the copy of the move, does it?
Defining your own constructor, a normal constructor that takes arguments, no, that's fine.
Yeah.
That's absolutely fine, yeah.
You'll still get a copy of the move.
Absolutely, yeah. Insofar as it's possible with the restrictions of your bases and data members, yes. And again, just don't do this kind of stuff unless you are actually comfortable with the language's semantics, which I suspect you're probably not right now. Sorry, yeah.
So, what is the relationship between the constructor and the argument, please?
So the arguments that you take are telling people who want to use your class, okay, if you want to construct an instance of my stuff, I need this, this, and this from you. Okay, so maybe I say in the case of the student, right, I need 2 strings. I need one for the first name and one for the last name. In order for you to construct me, give me a first name, give me a last name. Just up, you're defining the data you're willing to or requiring, the data you're requiring in order to initialize your class. What you do with it is up to you. In the case of student, I took those 2 strings and I stored them into my class, right, into my instance of the class. But maybe you don't need to store them, you just want to print them or temporarily use them for something, right? It could be a piece of transient data. Maybe you give me a string of JSON data, and in my class, I then transform that into some sort of abstract syntax tree, for example, yes.
Could I give them default values in case the value is not supplied?
Absolutely you can, and it's highly encouraged. As Tristan has said before in previous sessions about initializing your data, yes, always do that. Sorry?
Would I do that in the constructor or in the declaration of variable?
Since C++ 11, you'll be happy to know that you can in fact just do it where you declare the members. So let me if I just jump back so you can see it clearly. I'm on 16. Okay. So if we look at this, since C++ 11, here you can just do equals and then whatever you want, and that will just happily work.
What would be the old way?
Sorry. So the old way would be that I would declare a constructor, student. I'd get rid of I'd overload it, right? So I'll have another constructor right in here, student, no arguments, and then just some empty curly braces, and that will default because these have a default constructor anyway. So I just declare my default constructor and off we go.
In the old way, if you wanted to create a default argument, it would have to be at the end of the list.
Oh no, sorry. Yes, good point. That's a good point. Actually, in terms of default constructing the sort of quote unquote old way, you could. Actually, maybe Tristan might correct me here. I'm pretty sure it's legal. I believe you could do equals and then whatever default value you'd like for both of these. So you could have first name equals John, Joe, last name equals blogs. You'd be defaulting the arguments, but you're not actually creating a default constructor there, strictly speaking.
My point is,
Oh, you are? Okay, never mind, you are.
if you had 2 arguments and you wanted to default one, that one that you were defaulted had to be the last of the arguments.
Yeah, again, yes, the same rule applies. You can't default an earlier one and then not default the last one. So yes.
Can I just say, so that means that if you've supplied default values, then you implicitly created a default constructor, and therefore the rules you mentioned with every thing you inherit from must have default constructors will be fulfilled.
No. Oh, sorry. No. So you're making your own default constructor, right? You're making your own. So if the stuff below you, the base class doesn't have a default constructor, no, you must also call its constructor. So whatever constructor it is.
I mean the other way around. So if student here had default values, then our student would have.
Oh yes, absolutely. That's correct. Yes. Yeah. So just quickly, the question was if student was default constructible, would art student be default constructible? And the answer is absolutely. Let me just go back to. Sorry.
Art student wouldn't automatically get a default constructor. You'd still have to declare.
No, if student was default constructible, and art student declared no constructors, it would be default constructor.
Not as written there.
No, as written there, you would have to add it because it has one that takes arguments. Again, if you have a constructor that takes arguments, you suppress the default constructor, right? I could add this line to bring it back, so I could do art student brackets equals default, and that would bring it back for me. Yes.
So there is. Do the number of default constructors depend on the version of C++?
There's only ever one default constructor. You can't have more than one default constructor. I can't have multiple overloads of something taking no arguments, right? I can only have one. There's only one. I can't, even if it takes parameters, right? I can have a constructor that takes a string, right? I can't have another constructor that takes a string, because which one should it use? It has no idea. You can only have one for a given set of arguments or no arguments.
And that is not to have an argument.
Yes,
That's
the absence of an argument. You can have one constructor that takes no arguments, and we call that the default constructor. And you can have one that takes one string, but you can only have one of that. And I have a constructor that takes 2 strings, but I can only have one of that, right? Because if I had 2 of them, that couldn't ever be legal because there's no way for the compiler to know which one I'm intending to use. So you can have multiple overloads of constructors, but they have to take different stuff. They must be unique in some way. So, assignment operator rules. So who here has heard of, knows a little bit about operator overloading first? I'm hoping this won't be too unfriendly. Okay, that's not so bad, cool. Operator overloading is really not that complex, so hopefully I can explain it for those of you who are unfamiliar. So there's 2 kinds of implicitly generated assignment operators. The first one is what we call the copy assignment operator. So as you can probably guess, right, it's called operator equals, so this using the operator keyword. If I have an instance of, say, student, so I have, say, student X, yeah? So the instance is X. If I do X equals some other instance of student, well, I'm trying to do an assignment, right? You know, I can have in I equals 5, right? Well, ints are simple, but I've got my own class, and for convenience, I want to let people just use the equals sign, right? It's very quick and convenient for them to code. So I can make this function, which the compiler uses. If the compiler finds this function, it will dispatch to it. So it says, you know, I do X equals some new student, some other student instance, and it looks inside my class and sees that I have the operator equals. It goes, oh, cool, okay, you've got this. The thing on the right-hand side of the equals is the argument. So on the right-hand side of the equal sign is this other student instance. Well, that is just the argument to the function. And then, of course, we have to return a reference to ourselves because I could potentially do X equals something equals something. I could chain up, you know, it'd be silly to do so. Do equals, you know, A equals B equals C kind of thing. Right. And the moved assignment operator, again, optimization, don't worry about it, relatively similar, but it's taking what we call a movable value category. And as I said, they're just called when you use equals to copy or move data from one instance of your class to another instance of your class. And you can write your own overloads, right? I can write one that instead of taking my own type, it takes an int or a string. That may not make sense, it depends on what you're doing, right? So in the case of my student class, I could have an assignment operator that took a string. That's probably not really helpful because is that the first name? Is that the last name? I don't know. Not really a sensible option.
If you had like a matrix, then you can use a transformation.
I mean, I could probably have an equals operator that takes like a std array of strings, because then you can have a std array of 2 strings. So then I can say, well, the first one's the first name and the second one's the last name. So that could be an operator overload that might make sense, but who's realistically going to want to use that? I'd probably just do set name and then first name, last name.
So these all work with templates?
Absolutely, yeah. But yes, again, avoid writing these things unless you know what they do. The compiler can generate these. As I said, they're implicitly generated. They do fall under the same rules. Sorry, go on.
For the move assignment, you return a reference to a D.
To our own type, yes. You could make it void if you wanted, but it just makes it a little bit.
Return the same thing they take.
Sorry.
So it takes some.
Yeah, but you're meant to. The reason you do this is you can return an instance of you return the instance of yourself. So you can do in brackets, right? X equals whatever, close brackets, and then because it's returning an instance of itself, you can chain up more stuff onto it. So you could do dot some member function. It's just for convenience, huh?
Can you return a move one?
T-ref. No, it's not. I mean, can you physically? Yeah, you can write it. It's not strictly considered to be the operator. It's not conformant, but yes, the compiler will let you do it. It's a bad idea, but you could physically do it. Yes. Right. Yes. Avoid writing them unless you need to. Generally speaking, the compiler is going to take care of these things for you. And I think my mouse is there. We go. Yeah. So if it does make sense, you can define an operator overload that takes some other type just to make your class more convenient for people to use. So for example, stood string, right? You can use, equals on stood string and give it some characters that you've just written in your code. That's an operator overload. They did that in the standard library for you because that's convenient to use. And bear in mind that if you do want to get fancy, if you write a copy operator, it suppresses the move operator. And if you write a move operator, it suppresses the copy operator. So either write both of them preferably, or don't write either. Okay, on to destructors. These are fortunately slightly simpler. So first of all, the compiler always generates a destructor, except when any of your data members or base classes are not destructible, except that's incredibly stupid and useless. And somebody would have needed to mark their destructor as private or deleted. And I don't ever expect you to find this in any kind of real life sane code out there, because the only way to use an object that has done this stupidity is to construct it with new and leak the memory, which is not very useful. So if someone ever did this, they are literally creating a type that you have to leak, because you have no way of destroying it. You would have to do new and never delete it, just leak the memory. So in practice, this is ridiculous. Sorry?
Reason for version 2 of your program.
Yes, a reason for version 2. No destructor. Oh, terrible. Yeah, it's a question.
I would like to understand that, and it sounds funny for somebody who understands it. Version 2, what does it mean?
I think it's making a generic joke of, like, your V1 is basically garbage, and then V2 you fix up.
But, my question was, you have this kind of types. I've heard that you use the new keyword when you want to make something dynamic, and it's memory allocation.
Yeah, sorry. So new is a language keyword that says go to the operating system, ask it for a chunk of memory that's big enough to fit my class.
From the heap.
Precisely, from the heap. And then the OS, you go off to the OS and the OS gives it to you. But then the OS doesn't know when you're done with it. So you have to tell the OS, okay, I'm done with it, take the memory back now, please. And you use delete to do that. So new, that's it, the memory is yours for as long as you like, and delete says, okay, here you go, have it back.
So you would say it's not an everyday scenario, because usually all that kind of functionality is already somewhere in the language.
Yeah, so these days you'd use smart pointers, but the point is that if someone deleted the destructor, trying to call delete would be a compilation error. You will not be able to compile, because when you call delete, it calls the destructor as well. When you call new, it also calls the constructor, and delete also calls the destructor. And if there's no destructor, you can't call delete. So the only thing I can do is take that memory from the operating system and never give it back. I have no way to destroy the object and return the memory to the operating system, which is ridiculous. Nobody would do this. It's nonsense. Well, I'm sure there's someone out there. Who thinks they're really special and has done this. Like, oh yeah, maybe it's a missile. Who knows, right? Because you don't need to free memory if it's a missile. It's the ultimate memory garbage collection, right?
I mean, it could happen, actually.
Sorry?
It could happen when you're just writing code and you forget.
It's potential, but it will save you. If you always delete your stuff, you clean up your objects, and then suddenly you get a compile error because it's saying you don't have a destructor. The answer is generally not leak the memory. Okay, you can create your own destructor, unsurprisingly, and it allows you to run whatever code you like just before all the memory gets given back, returned, wiped, etc. But avoid defining it unless you have a really good reason to. So sometimes it can be useful for debugging, just to know when an object's got destroyed, so you can print to the console or something, right? So you can see it on the screen. Oh, I got cleaned up here. It can have its uses for debugging and such. And if you're interoperating with some C library where you have to call get resource and then release resource, you can wrap that in a class, because your constructor can do get resource and your destructor can do release resource. So when you're interoperating with C and stuff like that, it's very useful. But when you're just doing pure C++, you generally don't need them. Never allow exceptions. Who knows, familiar with exceptions before I get too ahead of myself? Exceptions, anyone? Yeah, okay, so cool, okay, we've got a few. So exceptions, similar to Java, I don't want to get into them too much because they deserve their own topic really. Basically, you can do what's called throwing an exception, and yes, precisely. And somewhere up in your source code, it will catch it, and everything in between the throw and the catch. So imagine all these classes I've created here. They all just get wound up and destroyed. So I go and I wind all the way back up to my catch. But you should never let them escape your destructor, because imagine this, right? I throw an exception. I'm winding up all these objects and destructing them. If one of them throws an exception in their destructor, that's what we call a double exception. We've thrown an exception while we're unwinding from an existing exception. Your program gets terminated. Bye-bye. So, consequently, either don't write a destructor, or do really, really simple stuff. Or have a try-catch in your destructor, potentially. Anyway, yes, defining your own destructor will make your life harder and potentially make your code slower as well. The compiler will not be able to generate a move constructor for you. Makes things a bit slower, but not fatal. And again, the assignment operator, which is also not fatal, but you lose optimizations. So let's see, what has the compiler done for me lately? Here is a very trivial class where the compiler is basically doing everything for me. So I have a std string. I then have a constructor. So I take the argument, construct my string from the argument. Doesn't need any code. I want to re-expose the default constructor, so maybe you don't have a string for me. Fine, okay, I'll let you do that. That's okay. So you can create an instance with no arguments. No problem. I'm going to let you do that. And then let's have a member function, so you can read the string. Does anyone see anything a bit wrong with this member function, perhaps? Correct. Which isn't a deal breaker, but it means if I have a const instance of this class, it's basically useless. Although I would argue that this class is inherently useless, because why would you ever want to use this? But yes. And of course, close it off.
So can you just say that point again? I didn't get it.
What was that, sorry?
What was wrong?
So there's no, I mean, this is obviously an inherently useless class, but there's no const here. So it means if I have a const done for me, I can't actually call getString anymore. So I would need to put the word const after the closing parentheses there. Then it would allow me to use it on a const instance. Makes sense?
I'll believe you.
Okay. So now I'm going to give you a class that does exactly the same, except I'm doing it all myself. I'm going everything the compiler's done for me here that I haven't had to write, I'm going to write it. So I'm calling this DIY because I've done it myself. Again, we have our string, very standard, public begins. We have a default constructor. Okay, this one's actually shorter, but it's actually inferior. This is better because it's what's called an explicitly defaulted default constructor, and it's more optimal for the compiler. It's also just good semantics. So this is more, not only is this more optimal, it's pretty damn obvious to anyone what they're looking at. This, yes, okay, it achieves the exact same effect because it takes no arguments and does nothing. But, yes.
Does it make any difference if you put this into goal code? Would that make any difference?
In the majority of cases, no. It's generally when you're going across ABI boundaries that it matters. And by ABI boundaries, okay, so if someone uses your class, when it's defaulted, they can locally just do whatever's needed to initialize the class. When, well, okay, if this is in a header, it wouldn't really matter, but if this was just a declaration, I did it somewhere separately, someone using my class, if they're in, say, a separate executable or whatever, a separate file, they're not actually allowed to generate the code to initialize this anymore. They have to have an explicit call to the constructor. And then, of course, we've got this, which is literally this. It's identical, of course. There's absolutely no difference between this one. It just takes an argument and initializes it. Then we've got the copy constructor, right? So if we have two instances of DIY, I want to copy the string in one into the other. We already have this here. It's just implicitly, we got it for free. The compiler did it for us, but I'm going to do it myself. So we have the other one, the other DIY class instance, and I initialize ours with the one in there, and that will obviously copy from there, that instance's string into our instance's string. It's our own type, right? It's our own type, but it's a different instance of our type. And now the move constructor, again, don't worry about it too much, but does the same thing, but I have to use stood move. Technically, I could not use stood move. I could remove the stood move call, and I'd have a move constructor that sucks because it actually copies. So let the compiler do it for you. And then we've got our assignment operator. So this is actually like a function. So I can do, you know, one instance of DIY equals another instance. This is the copy constructor, so this is const. And it's fairly simple, right? We've got string equals the other one's string. Fairly simple. And then of course we just return a reference to ourselves. So obviously this keyword, as it were, is a pointer, so we dereference it to get a reference. It won't compile because it's a pointer. It will just say, you said you return a reference, but in fact you're returning a pointer, you can't do that. Close off the function, because again, operator overloads really are basically just functions that the compiler uses for matching when users, when a user of your class is taking advantage of a symbol like the equals sign. And then of course the move one, and again, all this code, all these four things are they're here, they exist in here. I just don't have to write them, the compiler's doing it for me. And again, I could not do this, but my move assignment operator would suck because it would copy. And then we've got our member function to get the string, reproduce
so
the...
you don't have to write this?
I don't have to write these functions, not this. I have to write that. I have to write star this because I return a reference to my own class. But what I'm saying is the compiler's generating all these for me in the example on the left. And we have our member function. Again, I've reproduced the missing const, just for consistency with this one. And then we have a destructor. Again, pointless, does nothing. You could have also done equals default here, which actually then would not detriment you in any way. But there's no point. It's pointless, right? All of this is identical to this. Much less.
How inexperienced person could, so if they do their stuff on the left side, how they can reassure themselves that actually all of that on the right side, it's done?
That's difficult, really. That's a difficult question. So your main concern, right, is sorry. Oh, sorry, yes. Yeah, so the question was, for an inexperienced person, how can they have the confidence that the class on the left really is the same as the class on the right? I would honestly say to you that the concerns really are born out of performance desires and issues. So if you're inexperienced, you just want it to work, right? The most important code is the correct code, right? The code that is logically correct. It does what you want it to do. Once you've got the code doing what you want it to do, and once you've got tests that capture that it behaves correctly as well, then you can start worrying about performance. I can have a function that's extremely fast, but it also crashes the computer 9 times out of 10. It's not very useful.
I mean, what I meant is like, because you don't have like, you know, I do this and suddenly magically, you know, like some pop-up will come out and say, okay, you did it, it's done. Yes. The question is how the person can say, okay, yeah, the version which I did, yes, will allow me that functionality. And I know it, you know, personally, that's
yeah, I get what you're saying, but there's no really easy answer to it. I mean, basically, I think the answer here is become a better programmer, study, read more, get help from people.
How do you just test it?
Or you can, I mean, you need to understand move semantics to test this particular stuff. But yes, theoretically, you can test it. You could also use the type traits header that literally has template types that let you check if it has a move constructor or copy constructor at compile time. Yes.
There is an interesting website also working for C++ which actually visualizes all the objects that are created.
Yes, there is, and I've forgotten the name of it. But if you could link that on our Slack, that would be marvellous. Right. ROP, convenience and complexities, if you haven't seen enough already. And another great quote from Steve Gonides, I believe. I saw cout being shifted hello world times to the left, and I stopped right there. Everyone's seen the classic hello world example from C++, right? Stood C out, shift operator, hello world. Obviously, in other languages, the shift operator is for operating with numbers, not strings, so it is a bit silly. Right, so the explicit keyword looks quite intimidating at first, but hopefully this will actually show you that it's not. So C++ is helpful and clever. It's lovely, actually. Despite some of the complexity, it's generally quite nice to use sometimes. But sometimes it's too clever for our own good. And I'm just going to show you a bit of code. So I made a struct which I'm calling shift data. The contents of this struct are not important, so I've abbreviated it somewhat. It takes a const char star. That's all you need to know. Okay? It doesn't technically do anything, as it were, but pretend that all you know is this thing takes this argument. You don't need to know what it does. It's not important. And then we've got a function called launch the nukes. That's bad.
Is this where you would use the explicit constructor so that the constructor is not mistaken for a function?
We're getting there. Change shifts is fairly harmless. So we have a function called do operation. So this overload takes an instance of shift data, and it launches the nukes. Then we have another one, same name, a different overload. It takes a char star, and this just change shifts, harmless. So there's two versions of do operation. One of them takes shift data, which is this struct type, and one of them takes a char star. So now we have our int main, right, the entry point of our program. We call do operation, and we have a string, don't we? So what do you think it's going to call? Is it going to call this one that launches the nukes, or is it going to call this one that takes a char star and just changes shifts, right? Harmony means this is a character array, right? This is an array of characters. Seems harmless. So what do we think will happen?
I think you go for shift data. Yes.
Well, yeah, we just killed everyone, unfortunately. Well, that sucked, didn't it, a bit? That really sucked. But why did it happen? Well, sorry? So I launched some characters into space. So the reason why is that this thing here is the string that says this seems safe. It's not a char star. It's actually a const char star. So when the compiler looks, it says, well, okay, this is a const char star. You're calling do operation. Well, this one's no good because it's not taking a const char star. Tough. But what about this one? Well, this one's taking a shift data. But shift data that's its own type. It's not actually a const char star. It's totally separate. But it says, well, actually, let's have a look at shift data. Can we construct a shift data from a const char star? Well, actually, yeah, we can. It's fine. So let's take this, use it as an argument to construct a shift data, and then just call this with it. Give it to this. No problem. Works. That's why that happened.
But the code will be read, not like you read from the bottom. It will go from the top. Am I correct? So first we'll go to struct shift data.
So strictly speaking, it wouldn't matter what order. So if I put const char star here, even though this came after this, it would then match this because that would be a preferable match. It wouldn't require conversion, right? Avoiding doing a conversion, because I have to convert this thing into this thing. If this took a const char star, now I don't have to do any conversion. So one way of fixing it is just make that const char star, and even though it comes afterwards, it doesn't matter. It's the best match. Yes.
So I'm just saying, there's a version of your question if we've done two definitions of the same do operation kind of thing, but with the two similar arguments, that would it read one then the other? Is that?
No, there's a.
Yeah, you're asking about overload resolution order. No, the overload resolution does not depend, because these are overloads, right? Just to be clear, this is one overload, this is another overload. Overload resolution does not depend on the order in which you've put them. It depends on what types they're taking and what is the best, most specific match. But anyway, let's fix it. And you can probably guess from the title what I'm going to do. Whee! Explicit. Done. So now we're saying, what this is saying to the compiler is that I don't want you to do a conversion, okay? So this guy isn't asking for a const char star, and this isn't shift data, and we're now saying don't perform explicit conversions, please. We don't want them. So someone can construct a shift data. They can have shift data x, and then curly braces or brackets, and give that a const char star because I'm explicitly initializing a shift data. So that's fine. But this is not explicit, right? I thought I was going to call this, and it was implicitly converting it for me. Simple enough. So we're done with that. As I just said, it will look for a compatible constructor or conversion operator. I will cover conversion operators in a separate session, but don't worry about them too much for now. But just so you know the rules, two ways of doing conversion doing this implicit conversion is through a constructor or something known as a conversion operator. But it only is relevant for a constructor when the constructor takes one argument, because obviously if it took more than one argument, and I call the function, that one parameter is a single argument. If a function takes multiple arguments, multiple classes, it can't consider all of those parameters as an implicit conversion for one class. You can only consider one parameter per class per conversion. And if the constructor does not provide a default for the argument. So if you have a constructor that takes one argument and you did, int, for example, so the constructor takes an int and you said equals 5. So by default, if you pass nothing, it will set it to 5. Then the compiler says, okay, we're not going to consider this one because your class is saying, if you don't give me anything explicitly, I'm just going to assume you want this, and then it is not considered, just like if you used explicit. However, C++11 loves giving us new ways of initializing things, and that then change the game again. So if a constructor takes multiple arguments, it can actually weirdly benefit from having explicit on it. And this is the only example of why. So if I have, imagine a my class constructor which takes int, int, int. If I use the assignment operator with what's called an initializer list, because if I make it explicit, so I have explicit my class int, 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 then it won't match and this won't compile, which probably isn't that useful really. You probably do want it to compile, but it's worth knowing if someone's got an initializer list, you can use explicit to to prevent it from compiling. But this is still fine, of course. If you don't use the equals sign, no problem. But again, it's just C++11. Complexity. Sorry?
What's the point of that?
Well, I'm just mentioning it for completeness, but it's obviously daft, isn't it? I think it's daft. If I can find an example where that saves you, I will be sure to let you know, but it's worth it.
Is that because the equality sign overrules the...
No, it's because so the reason it is because this is now its own type. This represents what's called an initializer list. It's like it's an actual object, as it were. So by what it's saying is that, well, we want to initialize this from an initializer list. Can we convert this initializer list to a series of ints? And without explicit, it can. Well, the answer is yes, it can convert it. But if you put explicit, you're saying, well, yeah, I know you can convert it. Please don't. If you removed explicit, and obviously again we're allowing the conversion, and it will work. But this is not an initializer list. So this works just fine in either case, because this is not an initializer list. This is because of the equals sign, creating this as an object here. Right, nested classes. Again, hopefully this is fairly straightforward. You can define or declare classes inside others. You can keep going as deep as you like. And that inner class, the class inside, can access everything of the class immediately outside of it. It's immediate parent, if you like. The private members of the immediate parent can be accessed from inside the inner class. But the outer class does not get the same benefits. So the outer class cannot see inside all the private stuff of the inner class. You can also make the inner class public, protected, or private. So you're declaring an inner type, and the visibility of that type can be whatever you want, same as everything else. It's all fair game. And if you restrict access to it, so this is where it gets very funny, is that you can have a public member function, right, that will return an instance of your inner class, which you made private. So your inner class can be in the private section of your outer class, But you can have a public member function that returns an instance of it. And that way they can interact with instances of it, but they can't actually construct one, right? Because you made the type itself private. So they have no way of saying, you know, inner T this, because it's private, they're not allowed to access it like that.
If you, sorry, on the second bullet point now, if you were writing a program and you just say you wanted to access private members of the class, do you not just embed a class and then just see out all of the private data inside
Well,
that
if you
class?
have the ability to modify the definition of the class, then why would you bother doing that? You can just change the word private to public. I mean, you're saying you're talking about a scenario where you have the ability to modify the class, right? Putting nested classes in counts as modifying the class.
Yeah, I suppose you can change it.
Yeah. So if you've got that level of access, you can do whatever you want anyway. So yes, if you restrict access, you can still return instances of the inner class, and they can interact with that, but they won't be able to construct it because you made it private. However, you can kind of punch a hole in it with C++ 11. Because if you return an instance, they can use the magic decl type keyword, and then they could create an instance. So it's a bit less effective. There are a few strategies which I did research as part of this that protect against it, but I don't think it's worth bringing up this early in the module at all. And realistically, it's having private inner classes. Usually, you don't want to expose them at all to the outside ever. Yes, they can be good design in some cases, but don't overuse them. They're going to bloat your class somewhat. It makes sense for transient data though. So, for example, I might have an inner class that's just got, you know, a couple of strings in it, whatever, and it doesn't have any functionality. It just happens to be a way of organizing data. One of the things you can use a struct for, right, is it can represent functionality, and that is ROP. But then we can also use structs just for grouping data together, right? We don't give the struct any functions. We don't have anything private, nothing fancy. It's just got data, a couple of strings, ints, whatever, right? The point, the data inside is not important. You're using it as a way of grouping together some data. And having inner classes that simply group together data, yeah, pretty reasonable. And with that in mind, you probably don't want to expose it to anyone. So don't return instances of it, don't make it public, maybe make it protected, depends on your use case. And if somehow you end up in a situation where your inner class is doing more stuff and has more functionality or data or whatever than your outer class, you've probably done something wrong there. You want to go and sit in the corner and think about what you've done. Right. Well, we've got about 15 minutes, so this is pushing it, but it might be able to get cracking at least. Again, another lovely quote from Bjarne. C++ is designed to allow you to express ideas. If you don't have ideas or don't have any clue about how to express them, C++ doesn't really offer much help.
So is there a way around that? Like, this goes back to the discussion that we had about how do you find your classes.
Hold that thought for a second. So just to get cracking, here's the exercise. I will copy it to Slack right now. Yeah, go for it. Sorry, your question. I'm trying to copy it. Oh, here we go, got it. Right, it's pasted on the Slack in 3, 2, 1, there you go.
The links are also posted in Slack.
Yes, it is in CPP London Uni on Slack, and if Tristan will copy it to the YouTube in a moment, I hope as well, or Tom. So I designed this particular exercise so that as long as you don't make any invalid syntax, it will actually just compile, and it will then run and tell you what you got wrong. Sorry, question.
Yeah, so when he says that you want to express your ideas, C++ isn't much help, this goes back to the conversation we had about how do you find your classes and stuff like that, because you will be using like classes or some other kind of code to express what it is you want to get across.
Yes.
If you can't find your classes,
If you can't
find your classes,
find
you
your
can't find your structs to represent what it is you want to represent.
what do you mean by find?
Well, so you want to represent something, you've got to find a class to represent that, or a struct.
You don't find a class, you define a class, right? You're going to think about your problem, and then break it down, right? So for example, let's take HTTP, right? The HTTP protocol. So I can. This is kind of off the cuff right now, but I know that HTTP is a series of headers, right? So the first thing I'm thinking to myself now is, I'll have a header class, right? That can represent a single header, right? And then, well, the headers are part of a message. So I'll probably have a message class, and then that message class will have probably a vector of headers, right? Because you can have multiple headers in one HTTP message. And then, well, that also has a body actually, doesn't it? So there's a body in an HTTP message as well. So I need to go off and make a body class now to represent that body, which could be binary data. So maybe I need to have a base class that represents a generic body, but then derive from that for a binary body, which is like some file. And then I'll maybe have one for an HTML body, which then represents all the plain text HTML. So that's just an example off the cuff.
You say that because you've obviously got like a lot of experience in finding just recognizing what classes they just pop up to you. But like for the novices, that would be quite a stretch. Like you could know all the syntax.
Yeah.
How would you? So basically, what would you do to get to the place where you can just say, okay, I know what classes to pick?
Honestly, it's a really good question, and it's also probably the most difficult question to answer as well. I'll get you in a second. I honestly don't have a good answer for it. If there is a good answer out there, then someone please feel free to share. I mean, we're really asking, right? How does one reason about a problem and break it down into subtasks? And I do agree with you. I think it is a very difficult issue to approach. I sadly don't have a good answer. I mean, for me, it's been something that I don't want to necessarily use the word innate, but it's something that definitely felt like it came naturally, which is not a great answer in itself, but it's the best I've got at the moment, I'm afraid. Yes, question.
We had one teacher who gave good advice. It's like, first of all, start programming with a pen, not with a computer. And second, try to break it down into its elements. Try to define first everything in a function.
Yeah.
And then you see what makes sense, what doesn't make sense. And the best thing is to do that in sorted code, because then you can actually see on the fly, do I need the concept that I wrote here in the beginning, or is it already somewhere defined in the code?
Yeah. I mean, you could maybe you can think of it in terms of just English as a language, or any language realistically, right? So I was talking about HTTP has messages. So I'm using adjectives as I go along, right? And I'm saying, okay, adjective, let's make that a class. Another adjective, make that a class. Like, maybe I don't know if that's viable in all cases, right?
I came across something written by, is it Bertrand Mayer? It's a really old work. It's really interesting because it's about object-oriented programming just at the start of it, and he was saying how this stuff is going to completely revolutionise the world. So he wrote it back in 1993, and now when I'm going over
93.
Sometime around then anyway.
It's not that old.
But it's interesting that he wrote it before it was fully adopted.
Yeah.
And he was he came up with a whole mathematical approach to finding classes, which I don't know.
I mean, I feel like programming is largely a creative endeavour, right? I suppose it's like you ask an artist, how do you decide what you're going to paint, and then how do you decide what pieces you want on the canvas? I think that programming is very much a creative thing in the sense of OOP, which is actually why I quite like OOP. It's a way to design and create something that you can be proud of and also have, dare I say it, have fun doing. So, I mean, it's something that will come with time. Looking at other people's code is probably a good way. Just go and watch YouTube videos of people doing live coding sessions, doing good OOP.
Is taking other people's code and then modifying it and making it your own, is that mediocre programming, bad programming, or okay programming?
I think it's all free. It depends what you do with it. If you take some nice code and turn it to absolute garbage, it's terrible. If you take some garbage and make it beautiful, that's amazing, right? It just depends on what you've done. Also, if anyone needs help with the exercise, please feel free. It does require C++ 17, so do make sure that you have an up-to-date compiler, especially if you're using Visual Studio. Sorry. Generally speaking, I use 7 GCC. Yeah, what am I saying? Yeah, sorry, Dan.
Well,
However, C9 how used the most.
No, Visual Studio Code.
okay.
Yeah, I've done it.
It said something about you have to use C method and then you have to create it via generator.
So if you particularly want to use it, the easiest way to use it is to install Visual Studio, install the manual, start, make a project, change an option, click a drop down, set it to type, and done. Build.
So you may have been looking at if you want to build the whole plan right from source.
Yeah,
that's
it's
really complicated. Whereas you need to have a C++ compiler. But for Windows, you can pre-build binary plan.
Because I was on the website, they said if you have Linux, everything is fine. Otherwise, you have to build it for source.
No, that's nonsense.
All right.
Go to source, yeah.
Did you find a website that shows you what's happening?
It's on Slack. Somebody has posted it.
Basically unwraps a bit of syntactic sugar, like shows you what's really happening.
Oh, okay. Oh, crunches.
Yeah, LLV and all. Lima victim. Yeah, Windows 64-bit, that's not fun. That's the one you want, just run it, but the caveat is that you want Visual Studio to use it friendly.
I can't do it from the editor.
If you're familiar with CMake, you can invoke it manually from command line. That's not very friendly. If you want friendly instances, you're going to have to use Visual Studio. Otherwise, start learning command line, I guess.
Well, I mean, that's the way that I use GCC.
Oh, you're just invoking it from the command line.
Yeah.
That's not good sort of.
But I've had it on my hardware with executable from C9++. And it always told me that the program was not running even though I had a even using even setting extra flags, for example, use C++.
If you have it installed, do a command and show me. I can figure out this one. So who's managed to get some of the errors to go away?
Yes, so if you
Run it with nothing done, it will tell you a bunch of errors.
it's off the end of the thing you are so yeah.
So I've got constructor.
Course materials, SDL, 40 that should have sessions in there. Oh, no, we haven't done sessions then. We had short 7 sessions. Yes. You two were there for that. So those were all the PDFs. Well, this was the third module. The SDL was the third module. So the first one was like initial sequence. Reference to the string functions. And what called functions. And the second one was about writing types. Basic strings. So again, that's stuff in functions.
Just on speed.
Just in the hatchet.
Well, actually one, but I don't think you need to.
It is.
Thank you very much. Salvy's downstairs and wants vegetarian pizza.
I can sign him in.
Well, you had to do this.
Yeah. Why didn't? Oh, who answered the phone?
To who?
When did Sard call?
You didn't call.
When did they call for him? So he can come up. He can just go to the desk and get signed in.
Oh, I thought he had to have had to have a name badge or be escorted by someone.
No. I don't mind. I don't mind Sard. He's fine. It's just generally, yeah. He's supposed to register. It's a bit of a pain in the arse, but they'll call. And actually, yeah. Where is my phone now? Someone, you got my phone?
Yeah, you do.
Yeah, it's outside. Don't worry about it. Keep it clean, so sort it. Bottle caps don't matter. Oh, okay. Hmm. Yeah. I fancy that. Hello? You have Sard, right? Yeah, that's fine. You can send him up. Thank you. Bye. They are, yeah. We'll wrap up in about 5-10 minutes.
No, that's okay. So you want to check either the 1 and 2 are the same. Sorry, either the 0 and 1 are the same, or 1 and 2 is.
Yeah, so 0 and 2, I need to check that and that are the same, and this one's different.
Okay.
And failing that, then this and this are the same, and that one's different.
Okay. Just it.
So I could do like, let not be 9 and let be j equals 5 plus 1, and then I could. Or I could use that. This is assuming that we're going to be sorted. So then I sort of reload the.
Oh, okay. They're already sorted.
So I'm already sorted.
Okay. Hang on, I want to do that. Right, there's a function called adjacent find. Adjacent find. And what that will do is it will, whenever it comes across, it's for sorted ranges. And what it will do is when it comes across a pair of values that are the same, the first pair of identical values it will return you an iterator to the first row. Right, so what we can do is call adjacent find, and this, these two values are the same. We'll return an iterator to this one. These are different, and these two are the same. We'll return an iterator to this one. And if all three of them are different, we'll return an end.
Adjacent find.
The only thing they roll right now is if all three values are the same. And they're not, so see these first ones, and they'll turn this way. So you'll still have to run check and make sure that those two are the same.
Is there any way that you could see how it
As in like the implementation.
Yeah, how it works, because then I can just do that, classify it.
Yeah, I think we should wrap up. Okay, well, thank you everybody. Sorry, you done it? Does it say you passed? Oh, that, okay, sorry, bear with me. Yeah, thanks everyone. As usual, we're doing the pub. And please support us on Patreon if you like what we do. It means ever so much to us, and it will help us with getting hopefully a permanent home as well.
Thank you very much to Ollie for the class. So, as Ollie mentioned, don't forget the pub, and I hope to see you next week. And please do leave the place spotless clean, so we will not get into trouble with the big boss.
I did not get that.
Okay. By the entrance, so when you pass the lift, yes, continue, yes, so you, the doors are open, go, you pass the lift, and there will be second door on the left.
So I should have said, should I? Should have just let you suffer quietly. One of those video chats.
Right. Let's end this. Oh yeah, I've got to have to cut that off the YouTube. Well, thanks everyone who's on YouTube for watching, and toodles.